Okay, welcome back. Sorry about that little glitch in the last one. Took a while to figure out that 6 times 4 was 24. Okay, what do we got here? It says example 2, solve using the quadratic formula. Okay. You still must have it in standard form. It still has to be, it's got to be in that form, including equals 0. So, m squared minus 2m minus 4 equals 0. The quadratic formula says that it's going to be x equals minus b plus or minus square root b squared minus 4ac over top of 2a. You have to memorize that. So in this case, your x is actually m, but your a value is 1, your b value is negative 2, and your c value is negative 4. So m equals negative 2, so why not just put it in as positive 2, plus or minus 4. 4 times 1 is 4, times negative 4 is positive 16, over top of 2 times 1 is 2. This is going to give you 2 plus or minus square root of 20 over top of 2. Now we can do a little bit more with this question. 20 is 5 times 4. 4 is a perfect square, so it's going to be plus or minus 2 root 5 over 2. Notice I have a 2 here and a 2 here. If I think about that with brackets, I can put a 2 outside, 1 plus or minus root 5 over top of 2. And my final answer is 1 plus root 5 and 1 minus root 5. So there's 2 answers there. Next, this one. We're going to do it by using the quadratic formula. All right, I suggest you rewrite the quadratic formula every time you use it. I believe that you should say it in your head when you do it. Okay, and then I put a little box around it, and a is 3, b is 2, c is 6. So it's going to be negative 2 plus or minus 4 minus 4 times 3 is 12 times 6 is 72 over top of 6. So it's negative 2 plus or minus, now 72, I better make sure. 4 times the 3 equals times the 6, it is 72. Now, it's going to be negative 68. What's the largest perfect square that goes into 68? I'm going to try 4. 4 and 17. 17 is a prime number, so it is. It's going to be negative 2 plus or minus square root 4 times 17 times negative 1. Okay? So I'm going to think about that a little bit differently. I'm going to think about that as negative 2 plus or minus root 4, root 17, root negative 1 over top of 6. Root 4 is 2. Root 17 is root 17, and root of negative 1 is I. So I brought that up here, okay, so I don't lose it. It's awful if you put it on the end and it gets caught underneath that line, because then it's the square root of negative 1, which is not what you mean. We're going to common factor out a 2. I could common factor out a negative 2, but I don't think I want to. So it'll be negative 1 plus or minus I root 17 over top of 6. These will reduce, leaving me with negative 1 plus or minus I root 17 over top of 3. Okay, so there you go. I'm interested in this homework. That's probably from your textbook, page 49, 1, 3, 5, and 7. So that's where you're going to go, okay? That's going to be in your textbook. So this is your textbook, page 49, 1, 3, 5, and 7. That was an old textbook, so you're not going to use that one. And I think that, on the back here we have another page. Basically this just tells you how to do the solving with a quadratic formula with complex numbers. Okay, so basically it's everything that I've just done with you. So give this a read. Okay, so I want you to read the solution. There's two examples. There's example 1 and then there's another example here. And you can go over those and make sure you understand them. And then back here we've got some questions for you to do. And this again is in your workbook. And you can do any half. Do half of these. Let's do this half. Let's do 1 to 17. Okay? And then over here, the challenge problems, yeah, not too interested in it. You can stop there. Okay, so do this half. Now the answers aren't pretty. You really have to sort of squint to read them, but you'll be okay. Especially if you get them right, you'll figure out what's going on. Then we move on to lesson 2, and I'll come right back.